guys, welcome to my physics project / STEM day project video, which I decided to build or make a pendulum basically. Now I'll tell you the materials that you would need to complete this project. Wooden planks, some thread, knots to be specific I used the hex, scissors, a masking tape or any type of tape, a hammer and a bunch of nails, a ruler, and lastly yourself. Just kidding. And now I'll explain to you the process. So basically your first step is making your wooden frame. As you can see here, there are 4 legs of a pendulum, so you'd have to hammer them, except the middle part which your pendulum is attached to. So as you can see here in this photo, it's me actually hammering the nails to the middle plank. So for example, I want 14 pendulums, I need to hammer 15 nails to this wooden plank. You will not attach your middle plank to your legs of the pendulum together until you tie your pendulums together with the middle plank. So this is the second step, which I find it easiest, which is the calculation part. L equals GT max over 2 pi k plus n plus 1 squared. L is the length of your pendulum, of each of your pendulum. G is the gravity, which is 9.8. 24, or the T max, is basically the amount of time you would want your pendulum to swing in as a wave pattern. K is the constant value that we will solve for. N is the number of your pendulum. So as you can see here, I solved for K, and we're going to use this value to solve for each and every single pendulum. This is the calculation of every pendulum that I have. You can use this as well. The third step, aka the hardest step, is actually tying your pendulum to your wooden plank. Like I told you, I used tape to attach my wooden plank to this table or surface or any type of surface that you're doing this in, basically, and the ruler to actually measure the length of your pendulum according to your calculation. And we're done. You would actually attach your middle part of your pendulum to your 4 legs, basically. And it would actually be a scam if I'm not going to show you my final outcome. Yeah, I don't want this video to be a scam or clickbait that you're like, oh, so what's the point if you're not going to show what you did? So let's do it. Okay, I swear to God, this is not a scam and not a clickbait either. So I'm actually going to insert a photo of my pendulum, then a slow motion clip of my pendulum that, yeah, really interesting. It shows the wave pattern, so I hope you guys would like it too. It's really captivating, so yeah. So as you can see here, this is my pendulum. Nice, lovely, perfect, perfetto. So as you can see here, this is the slow motion video of my pendulum. I hope it looks quite interesting and not boring. Yeah, so that's it. I hope you guys liked the video. Please like, subscribe, comment, just kidding, yeah.
Hello everyone, so today we're making a pump from a DC motor for my STEM day project. So first, I start by cutting a cap of a water bottle into the shape and size that I want for my propeller. Then I cut a piece of 1 millimeter thick acrylic into 6 pieces for the blade. After I got the base and the blade, I did mark some lines to be my guide on where will I glue down the blades. a small container and make a small hole in the middle of it. And I put it into the motor, then I had my propeller glue on the motor. In this step, I really need to be patient, as I only want the propeller to be glued to the motor, but not the cap. I then glue the cap onto the cover of the motor to make it steady. For the other part of the container, I did make holes on it and I connect two silicone pipe into it. Then I put the two parts back together. Before proceeding to the next step, I first check if my propeller will rotate, and it does. Then I solder everything up. I did also add a switch so that I can control when I want to turn it on and off. Lastly, I make a box out of a cardboard and I put all my system inside. And this is how it turns out.
Hi guys, and today with me again, and today we are going to make a power rubber car. There are 8 materials that you need to prepare, which are scissors, soldering iron, rubber bands, glue gun, water bottles, caps, bamboo skewer, and cutter. Okay, if you already prepared all the materials, then let's start. Why are we waiting?
바람이 불어 따스한 햇살 속에서 우리 꽃향기와 함께 오늘 날이 좋아서 같이 걷고 싶어요 이쁜 이 거리를 너와 함께 지금 이 순간을 놓치고 싶진 않아 너도 나와 같다면 오늘 앞에 머릿결이 휘날리는 그 향기에 기분이 좋아서 너의 그 사랑이 피어나고 그대 품에 안겨 살짝 눈을 감죠 파란 하늘엔 구름이 하나 둘씩 새하얗게 꽃들을 피우고 우리 둘의 사랑이 시작되고 이 거리를 하나 둘씩 새하얗게 더 물들이고 있죠 밤 공기는 아직 차고 너의 손을 잡고서 이 순간에 서로의 따뜻한 온기를 느끼며 가로등이 비추는 거리를 따라서 지금 이 시간이 영원하길 지금 이 순간을 놓치고 싶진 않아 너도 나와 같다면 내 앞에 머릿결이 휘날리는 그 향기에 기분이 좋아서 너의 그 사랑이 피어나고 빨개진 물이 사과처럼 꼭 널 품은 나무가 되고 싶어. 너에게 사랑이 피어나면 해가 되어줄게. 바라기만 해줄래. 파란 하늘엔 구름이 하나 둘씩 새하얗게 꽃들을 피우고 우리들의 사랑이 시작되고 이 거리를 하나 둘씩 새하얗게 더 물들이고 있죠. 물들이고 있죠. yeah. 사랑이 시작되고 이 거리를 하나 둘씩 새하얗게 더 물들이고 있죠. 은은한 별빛을 위로 삼아 집으로 돌아가는 길에 흐린 구름 뒤로 가려진 하늘을 더는 바라보기 힘들어. 어두컴컴한 방 한켠에 작은 몸을 가득 채우고 나면 왠지 모르게 마음 한구석은 구멍이
Reading physics is only in your classroom or is being in real life. Let's take an experiment today. Let's go. Today we will talk about the talk. How talk being in our life. Let's go to see. First, you should know what is a talk. I'm searching on the website. Say, talk is a gravitational equivalent from line of force. It's also relevant to as a moment of force, gravitational force, or turning effect. Okay, this is a second example of a torque. This is the knot, right? If you use a hand to unscrew it, it's hard, right? Because it have a very small gradients. But we have a tool. Is this. It helps us to plus the distance of a radian of a moment. We use a force in this here to unscrew the nut like this. Like this. This is talk can help you easier to use a life. Okay, I will explain the talk by this diagram. So, this diagram shows range how it works. First, when we use the wrench, right, we will extend the force at the tip of the wrench, right, and we will make a head of the wrench turn around, right, and wrench we will make not turn around, follow it. So, at the load beam, we will make a resistance to roll out the knot, right? This is how wrench work by torque. Okay, second I will talk about the work in golf ball, golf cup, and your body when you play golf. In this pandemic, I can't go to golf cup and show the experiment about the golf, but I have to make some paper, some also that show. First, I will explain you about the Newton's third law because it's very important to describe how golf working. Newton's third law is a force when you action on something, it will action you back to you, like this picture. Okay, next I will describe about this photo that I have to make. First, I will talk about the work of your body. Work of your body, firstly, when you hit the golf ball, the shoulder will turn back to the right side, and at the same time, his shoulder is turned to the front. The back is turned in the same direction with the shoulder. The knee, the body weight will transfer to the left, and the knee will move to the left side of the body. When you stand on the fall, your weight will action to the fall, and fall will action back to your feet. Second, when you hit the golf ball, we will talk about the golf cup. Golf cup will hit the golf ball, then the golf cup.
Hello everyone, my name is Netakorn from grade 11 and I'll be showing how to make holograms out of CDs at home. These are all the materials needed for this project. I start off by drawing this shape on a piece of paper and cutting it out. After I've cut the shape, I traced the shape onto the CD and started cutting. I then found out taping it onto the CD and cutting it on top would be easier. I repeated this process 4 times until I got 4 pieces of the shape I needed. In the meantime, let's talk about how the CD hologram works and the science behind it. Holograms are created by the technique of physics known as holography. Holography entails the use of laser light for instructive purposes and to view the completed hologram. Holograms are not photographs. Therefore, it is an encoding of the electromagnetic field by way of an interfering of pattern, apparently arbitrary variability inside the obscurity, density, or shallow profile of the photogenic medium. In simple words, holograms are just light scattered from an object. Now back to creating CD holograms. After I have all my pieces, I sprayed them with alcohol and made sure they are clean and ready to be assembled. Now I put all the pieces together using tape and it should look something like this. Then you should place the smaller square in the middle of this video to see a hologram. You can find more of these videos on YouTube. The following clips will be the results of my hologram.
Okay, so we're gonna have an experiment about Mentos and soda. Show what react is gonna show us.
Before we go back to comparing two strings, let's talk about how does this process happen. Going back to the first thing I did, which was adding in salt and stirring it into the water until they no longer dissolve. What I basically did was to add salt until the solution is saturated, then I heat the solution to raise the solubility. The solution will become unsaturated. Technically it's still saturated, but most solution tend to have higher solubility as the temperature rises. Some solution have high solubility as the temperature goes down. But for this solution it goes up as it was being heated. As the solution heated up, I added more salt so it will be saturated again. I did that until no more salt dissolved. Then I cooled the solution down. As the solution is cooling down, the salt that was dissolving while it was hot will be spit out as the solution has become supersaturated. But it takes time for it to spit the salt out. And it needs some sort of center to form crystal. And that's the reason why the string is needed. It will act as the center for salt to form. Or at least something the crystal can hang on to. Now that we're done with basic, I'm gonna compare two strings, which one is the normal one, and other one which is the other one used for salt crystallization.
STEM project. Hot wheels. Equipment. Filter board. Glue gun. Cutters or scissors. Decoration. Stationery. racing or toy cars. Let's get started. To begin with, we have to cut the filter board to size width 32, length 247. You might measure the side first using measuring tape or ruler before using the cutter. Just this, we will get the part of the slope. Next, measure with 60, length 247 and cut it out. Measure from one side 30 inches and opposite side 47 inches. And draw lines together from one point to another and cut apart. Measure 5 cm and draw a line on both sheets. And cut 5 filter boards, arranged in order of height, each of which is width 32 inches. Then put them together using a glue gun. And bring the other side to stick together. Bring the slope to try to cover. Measure the side and use a cutter to make a notch. And fold it. Then bring it to try again. And use a glue gun to attract them together. And this is a rail made by using 2 cm filter board to block each length using a glue gun. And here's an oval wheel that has been decorated with sign already. And this is an experimental release using a car that has the same weight when we read. And then it can be seen that the duration is comparable or maybe slightly different. And this is an experiment using different weight cars. Number 1. Lightest weight made of plastic. Number 2 is heavy, made of steel. Number 3 has a weight made of plastic and rubber. It can be seen that number 2 is the fastest, followed by number 3 and number 1 respectively. Because when the weight is heavy, it will become down faster. This experiment deals with the gravity of the Earth. If there is a heavy transmission force or a lot of mass, it will fall quickly and hit the ground. However, fast or slow motion is caused by the mass of the object. Here is an overview of the Hot Wheels.
Hello guys, today I'm going to demonstrate how pressure works, and to do that I will need vacuum cleaner and a clear plastic bag. As you can see, as soon as I turn on the vacuum, the bag starts to shrink down. That's because the air pressure is lowered inside the bag and the outside is higher, so it's compressing the air inside into a sheet of blanket. This is another demonstration of air pressure acting on a bag with a human inside.
Hello everyone, I am Yuta Takaki. This video is the introduction of torque, and I will explain what does torque mean and torque in our society. Before explaining what does torque mean, have you ever heard torque in your life? I guess we don't usually hear the word. Oh, okay, let's go back to explanation. Torque is a rotational force that acts or works around the fixed axis in mechanics. Torque is no majority we have not heard if we don't study physics. As you see in the picture, force is pushed right outside the video. Therefore, rotational force is generated around the letter O because of torsional force by force A and B. Let's see what part of torque is used in our society. Mainly, what you think of when you heard the word torque is the name of the tool. But torque is also used as vehicles movement. And in this video, I will explain torque based on example of vehicles. Formula of torque calculation. Calculation of rotational force is rather simple and difficult. In this video, I will use simple calculation as basic explanation of torque. Formula is force times radius between axis of rotation times sine. Radius is called long arm as well, and refers to distance from axis of rotation. Force is replaced to how strength long arm was pushed, and sine in torque calculation is described that what angle did the force come from. Example: if adult pedals bicycle, large force by pushing pedal will be generated and bicycle will be able to move far away. On the other hand, child will not generate such a large force and distance becomes short. That pattern, torque is able to calculate by multiplying by distance from the crankshaft to the pedals and force to push pedals, or it can replace meaning to long arm or radius times force. Let's say long arm is 20 cm and force is 25 kg. The answer will be 500 kg per centimeter. What if force is replaced to engine? In the case of bicycle, rotational force is weak and not automatically moved by rotational force. In contrast, in the case of vehicles with engines, rotational force becomes stronger and faster Also, rotational force becomes automatically work until engine is out of fuel. As you see in the itemization, effect of containing engine is powerful and generate huge power. When studying how object rotates, torque is necessary to understand how a certain force causes a change in rotational motion. The tendency of a force to cause or change rotational motion is called torque, and it is one of the most important concepts to understand in order to solve rotational motion situations. Thank you for watching my presentation, and see you next time.
Get
Guys, today I found a video. They're using a mask and candle, and it fly like a balloon. So today I gonna try it. Let's see. Right now we are at the lab. So we use safety. We have lab gown and goggle. So our material, we have candle and mask, then glue, and then lighter. First thing we do is to stick the mask with the candle.
Years later.
Guys, do you think it's gonna work?
The unfortunate boy didn't know that something bad could happen to him.
Guys, so I finished sticking the mask with the candle. So next is I will light the candle and let's see, is it gonna fly or no? What the f? So now we have the problem is our mask burned, so it failed. So subscribe and let's see what we will do next video. Goodbye.
stars come and go. It's the light within my reach, not as distant as it seems. Dreams are moments not as long, yet we linger in the past. Tell me, do you feel?
The Newton's cradle is an apparatus which consists of several rocky spheres named after Sir Isaac Newton. It demonstrates the conservation of momentum and energy. Newton's cradle is a prime example of an elastic collision. In an elastic collision, two objects collide and return to their original shape, with no loss of total kinetic energy. The law of conservation of momentum states that the total momentum of an object interact with one another remains constant. This basically means that the total momentum that one object loses is equal to the one that the other object gains. Also, energy is conserved as the first ball is raised. The system's gravitational potential energy increases. If it is released, the ball gains kinetic energy as the energy becomes solely kinetic. As the ball swings past the equilibrium point, the kinetic energy decreases, while the gravitational potential energy increases.